Today we're going to talk about parabolas. And first of all, we should think about what the definition of a parabola is. Hopefully you will remember doing this in Algebra 2. And a parabola is a set of all points in a plane that are the same distance from a given point, called the focus, and a given line called the directrix. And we actually have worked with the first column of a parabola. All of them that we've worked with have been in function form, which was y equals. And what we did earlier in the year is we talked about the vertex and the axis of symmetry and maybe the direction of opening, along with the x-intercepts, the y-intercept, and where is the graph increasing and where is the graph decreasing. So this first column shouldn't be too different from what we were doing probably really back in maybe October or November. But the formula of an equation in vertex form for a parabola is y equals a times x minus h 20 squared plus k. And our vertex is hk, and our axis of symmetry is the line that goes right down the middle of the graph, split it in half. So if we fold right down the middle, the one half of the graph will land on the other side of the graph. The next two formulas are how do we find the focus point that we saw in our definition, and the directrix. We also saw that in our definition, and we're going to look at those when we do an example here in a couple minutes. When we do the first column here, if the direction of opening is if the value of a, which is the coefficient in the parentheses, is greater than 0, our graph opens up. And if a is less than 0, our graph opens downward. Finally, this last column, or last part of the column, length of the lattice rectum. I know, not the most pleasant of words to stand up in front of class and say, so I usually abbreviate it as LR or LLR. What it does is it measures the girth of a parabola. Is it a fatter parabola or is it a skinnier parabola? It gives us a way of comparing one parabola to another. And the way that we calculate the LLR is we take the absolute value of 1 over a. So the a from the formula in vertex form. So the difference here today is that we're also going to look at x equals. So if we look at the other column here, it's an x equals, but it looks remarkably similar if you compare the vertex. We have the same values, hk. The axis of symmetry now is y equals k, which means that it's going to be a horizontal line instead of our earlier x equals h, which would be a vertical line. Then we have the formula for the focus and the directrix, which I think will be better used when we see an example with this one. But the difference here, the contrast from the y equals type of parabola to the x equals type of parabola, is that when a is greater than 0, we open right, our parabola opens right. And when a is less than 0, we open left. That's the big difference. And if you think about it, I know you can't see my hand gestures on the video, But y equals, y on an axis goes up and down. So y equals, the parabola opens up or down. X equals on a graph goes left to right. Well, look at where we open. We either open right or we open left. So a little technique to help you remember. The LLR is the same. It's measuring the girth. It gives us a number so that we can compare one parabola to another if we need to. So when we start here with our example, which is on that other piece of paper because I didn't want you to have to flip back and forth. This first example is already in the proper form. We already have y equals negative 1/3 times x plus 6, quantity squared minus k. And from here, we're going to identify all the different parts in our chart. And the first part being the vertex. And the vertex is going to come from x plus 6. So we're going to make this minus 6. Because remember that our formula is x minus h. So we had to change the sign in here. This would have been x minus a negative 6 if we wrote it in exact form, exact vertex form. And then negative 2 is going to be the other value in there. This one, whatever the sign is on the outside, is going to remain the same. While we're thinking about it, let's write over here that h equals negative 6, k equals negative 2, and a equals negative 1/3. Because those are the values that we're going to need as we work through these different types of problems. The h comes from the negative 6, the k, and then the a is the coefficient on the parentheses. So now that we know that, we can also identify the axis of symmetry, which I abbreviate AOS. Well, if you look back at your chart, it's x equals h. So this is x equals negative 6. And you know that I'm picky about the x equals. This is representing a vertical line, so we need to have that indicated in our list of items here. DO is for direction of opening. And if we look at this one here, since A is negative, that means that our direction is going to be downward. And the thing is, if we don't know that, the nice part is it's very easy to type this into our calculator on the graphing calculator. So if we go to y equals, and luckily enough, I have that in there already, y equals negative 1/3, parentheses, x plus 6, quantity squared, minus 2. So when we graph that, we get this picture. And it's going to go a little bit off our graph. In general, this is a good problem, but it doesn't fit as nicely on the graph as some of my other examples do. And I actually don't really need this. What I want to look at is the table. So if we look at the table, we can find some values on here. Remember, we already know that our vertex is negative 6, negative 2. And then, looking at the table, well, we see negative 3, negative 5. 1, 2, 3, 4, 5. And as we scroll through the table, we can find some more points. Clearly, I'm looking for the ones that don't have the fraction in them. So 3, negative 29 is not going to fit on there very nicely. If we scroll a little bit more, maybe the other direction, as the board is already disoriented again.
It's a smart board. It's supposed to be smart.
So we get 6, negative 6, negative 2. But ultimately what happens here is if we draw our axis of symmetry, which is the line that goes right through the middle of the graph, this point here that we found is 3 spaces away from the axis of symmetry. On the other side of the graph, 1, 2, 3, we should have that same point. And it also happens that another point, and I don't know why I didn't see it, but I'm looking at my notes myself here, was 0, negative 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Somewhere down here. So over here, somewhere down there. Because I did ask for 5 points to be graphed. And hopefully your picture looks a little bit better than mine on there. But there's a rough approximation of what our parabola looks like. And now we want to go ahead and find some other values. For instance, the focus, the directrix, and the LLR. So that's when we really do want to look at our chart and our focus is part of the definition. And to calculate the focus of this, our formula is going to be H. And then it's K plus 1 over 4A. So the nice thing is we have our H labeled already. It is negative 6. And then our K we have labeled already. It's negative 2 plus 1 over 4 times A. And A is negative 1/3. And that is in the denominator. Negative 4 times negative 1/3 is in the denominator. When we type this in, which you know is easier said than done for me, but it's going to be negative 2 plus 1 over 4 times alpha of y equals negative 1/3. And when we press enter there, we'll get our value, which is negative 11/4. So it's negative 6 and negative 11/4. Right? Then our directrix. The nice part is, if you look back at the formulas for the focus, it's K plus 1 over 4A. Well, the directrix is going to be a line, but it's K minus 1 over 4A. So if we can get one of them typed into the calculator, the directrix then will be much easier to type in if we simply go back to our equation and we change that plus to a minus. And that's going to give us our value, which is going to be, when I get back to the problem here, our directrix is just y equals, and again, looking at the calculator, negative 5/4. And then finally, the length of the LR, and that is calculated by taking the absolute value of 1 over a, 1 divided by a, our a being negative 1/3. If you can't do that in your head, then type it in. But 1 divided by negative 1/3 is negative 3. And then what's the absolute value of negative 3? 3. Question.
I don't understand what the focus is. I've typed in that range everywhere I get, and I have not got the answer that you have.
So let's look at what the focus is, and then I'll pause for a minute and help out a couple people figure things out. But the focus is on the inside. It's a point on the inside of the parabola. It is in alignment with the vertex. So 1, 2, 3, 4, 5, negative 6, and then it's down here a little bit more. Negative 11/4 is negative 2 3/4. So the board's disoriented again, but it should be right there on that axis of symmetry. The directrix is here. It's the horizontal line. And what happens is that the distance from the directrix to the vertex is the same as the distance from the focus point to the vertex. And it's how a parabola was actually developed. So it helps. We may do an activity on Wednesday to help us kind of see that. But for the most part, we haven't done focus and directrix this year, but we've done, or the LLR, but we've done the others. We've done the vertex, the axis of symmetry, and the direction of opening. So the x equals type of parabola is the next one. And we are in vertex form already. And we're going to be doing the same thing. The numbers work out a little bit better in terms of what fits on the graph. But I recommend that you look at your chart as we work our way through these. And on this particular problem, like the others, let's start off with the vertex. And the vertex of this is HK. And it's going to be 3, negative 2. So if you look at the format, this is x equals a times y minus k quantity squared plus h. So that's where I'm getting the value. So HK is always the vertex, and as we move into the other different conics, or even you think back to circles, the center of a circle is HK. The axis of symmetry, again, if you're unsure, you can look at your chart, but the axis of symmetry is going to be y equals, and what I haven't done yet is identify what does H equal, what does K equal, what does A equal. Well, H equals 3. K equals negative 2. And A equals 1/4. And certainly if we have those values identified, it makes following the formulas a little bit easier. So it's y equals K in this case, which is going to be y equals negative 2. Axis of symmetry is still a line that's going to split the graph in half. When we fold it in half, one half is going to land on the other side. So our direction of opening this time, here's where the differences really start to happen. A is 1/4, it's a positive number. Are we going to open right or are we going to open left? We're going to open right. So let's get this picture graphed here, and hopefully I can have a little bit better picture than the last one. But our calculators typically don't graph x equals. So what I'm going to start with is I'm going to graph this calculator as y equals. So when we type this in, instead of x equals, I'm going to type in y equals 1/4 times x plus 2, quantity squared, plus 3. And I don't need to look at the picture. What I really want is the table. So once we've got that typed in, let's go to the table function here. And I'll scroll through things a little bit, see if we can find a couple of better numbers. And remember, well, so what I've got on here, and I'm going to go back one more time and see. So we've got a couple points here that are good points to work with. We got -4, 4. So let's write that one down. -4, 4 is one of the points. We also have -2, 3. Looking at the points that don't have fractions or decimals in them right now, just to keep life a little bit simple, we have 0, 4. And I actually saw one other point there. I don't know if it's helpful or not, but 2, 7. But think about what we did when we typed it in the calculator. I typed in y equals 1/4 times the quantity of x plus 2, quantity squared, plus 3. What did I do to the x and the y? I switched them. So when we come over here and draw our graph, what I need to do, and what I've been doing on my paper, is I've been writing y equals here. But what we really need to graph is we really need to graph an x equals. So we switch places of the x and y. So let's switch. And let's switch. And let's switch. And let's switch. So even though most TI-84 regular calculators, and there's probably some way to do it on the calculator, but I have no idea what it is. But now that we know that, we can graph 4, -4. 3, -2. 4, 0. 7, 2. 1, 2, 3, 4, 5, 6, 7, 2. And it says to graph with at least 5 points. But a couple things that we can continue to point out here. Our axis of symmetry is going to go through the vertex, which is here, 3, -2. So notice that 4, 0 is 2 spaces away from the axis of symmetry. On the other side of that axis of symmetry is a point that's 2 spaces away. So over here, this is 1, 2, 3, 4 spaces away. So 1, 2, 3, 4 spaces away. And I just switched colors there, but a much better picture for me, at least. There's a parabola. So it's a nice little technique if we understand the idea of inverses. We switch the x and the y. So what we're looking at here is I did the blue graph, which is y equals. I didn't draw it up there. But once I identified those values from our calculator, then I just switched the x's and y's to draw the picture. And now that's going to allow us, here we've got the picture drawn, to figure out what's our focus, what's our directrix, what's our LLR. So looking back at that chart, our focus point, and I think I've been writing in blue, so I'll switch back to blue. Looking on our chart, the focus point is h plus 1 over 4a, comma k. And we identified the fact that our h is 3 plus 1 divided by 4 times our a value here. Our a value this time is 1/4. And then our k value, the other part of our point, our k, we labeled as -2. This one is a little bit simpler to simplify because 4 times 1/4 is 1. So this is really 3 plus 1, comma -2. And you could still type it in your calculator if you need to. But 3 plus 1 is 4, -2. That's our focus point. Focus points are always on the inside of the parabola. So when we come back here, 4, -2. There's our focus point. And we can see it better on this picture, and I can talk about it better on this picture. The focus point is the same distance away from the vertex as the directrix. And when it's a whole number like that, I know that my directrix is going to be here. Well, how do I know that? It's the same distance. So this focus point is 1 space away from our vertex. On the outside of the parabola is where the directrix is. That is 1 space away. But we could also put this into the formula here, our directrix. And our directrix says that it's going to be x equals h minus 1 over 4 times a. So our values aren't going to change much. It's going to be x equals 3 minus 1 over 4 times 1/4. And just like the last time, those 4's cancel out. So we end up with x equals 3 minus 1, which is our x equals 2. And by the way, it doesn't matter to me if you graph the focus or the directrix. But sometimes you don't have to do any work because you can graph the directrix here. So here's the focus, here's our directrix. And the last part that we need to know is, what's the LLR? Well, the LLR is calculated by the absolute value of 1 divided by A. It's 1 divided by A, which is 1/4. If you need to, type that in your calculator. 1 divided by 1/4. That happens to be 4 when we divide. And what's the absolute value of 4? Well, 4. On this particular problem, we can see where the focus is. It goes through, the LLR. It goes through the vertex. Third time's a charm. It goes through the focus point, and it is perpendicular to the directrix. If you count the squares here, we've got 1, 2, 3, 4. These we were lucky enough to have whole number points there as well. That's where we measure every parabola to identify the girth. Is it a skinny or a fat parabola? So now that we've seen a parabola where one of them is an x equals format, the other one's a y equals format,
That's no.
what we have to do is we have to identify what kind it is when we look at these remaining two examples. The first one, well, any thoughts? I'll throw it out to you first of all. Any thoughts on whether you think that this is going to be an x equals or a y equals parabola? And I've got a couple people saying x's, and you are correct. So the thing is, it's y minus 3 squared. So I'm just now noticing that I think one of my formulas at the very beginning is not right. Let's go back and look at that for a second. Because I've got y equals a times x minus h squared plus k. And then over here I've got x equals a times, this should be a y right there. I am so sorry about that. Back there on the chart. Now that you can't see it with that mark there. X equals a times y minus k squared. That was a big thing, and I did not see that until we're getting ready to start the third example. But now that we've got that fixed, that will help a lot. And when we simplify this problem, the first thing that I'm going to do is I'm going to divide both sides by -2. We don't need to distribute, we could, but that leaves us with x minus 4 over here on the left side of the equation, and then we can rewrite this as -1/2 times y minus 3 squared.
-2 underneath it.
You could put a -2 underneath it, but I'm going to identify that as an a value here in a minute. Well, you divide by -2, so those cancel out. And so the number in front of the parentheses is a 1, if there's nothing written there. So then we can add the 4 to both sides, and we get x equals -1/2 times y minus 3 squared plus 4.
That looks like x equals.
And there for sure, we're at x equals. So as we start with our vertex, now that we've got it in the proper form, then our vertex is going to be 4, 3. Before we get going too far along, let's identify what h is, and k, and a. Our axis of symmetry is, as I look at the chart, it's y equals, well, it's y equals 3. Our direction of opening, well, our A is -1/2, and so when we look at our chart, when A is less than 0, that means we're going to open up left. But when we go to graph this here, we're going to type into our calculator here, this is going to be the y equals format. And then to get the x equals, we will switch places. So maybe I'm the only one that has to make the table, but I find it helpful to do that. But as we go to our calculator and we go back to y equals, and we type in -1/2 times x minus 3 squared plus 4, and I don't look at the picture because it's not the picture. I do kind of try to go back and look at the vertex. 4, 3 is our vertex, which means that in this chart we would be looking at a value of 3, 4. But let's see if we can get a couple points here. And we've got 1, 2. And then we have 3, 4. If we look at some of the whole number of points, I saw 5, 2. And I kind of skipped a point. It's up there, and I saw it lastly here. But what about -1, -4? That's a whole number point. So if we have a regular calculator, all that we have to do now, because we switched x and y when we typed it in, is that we need to switch x and y here. So this is going to be 2, 1, 4, 3, which matches our vertex, 2, 5, and -4, -1. So when we draw our picture, there's 4 out of the 5 points. We could have found a 5th point, even. So 2, 1. And 1, 2, 3, 4, 1, 2, 3. 2, 5. 1, 2, 3, 4, 5. Over 2. 1, 2, 3, 4, 5. Our other point that I found, -4, -1. And let's put in the axis of symmetry, which goes right through the vertex. And what we can see once again is that this point 2, 1 is 2 spaces away from the axis of symmetry. And our corresponding point on the other side of it, on the other side of the axis of symmetry, is 2 spaces away. So this value that we just graphed, this -4, -1, it is 1, 2, 3, 4 spaces away from the axis of symmetry. So on the other side of the axis of symmetry, 1, 2, 3, 4. But we just as easily could have found it on the table. And do the best we can not to make this pointed. But there's our graph. And then we can find the rest of the values here. We want to figure out what the focus is, what the directrix is, what the LLR is. And so, again, I ask you to look back at your chart. And our formula for the focus is h plus 1 divided by 4 times a. Okay. And I'm just reading it straight up your chart. We already identified what does h equal. It equals 4. And it's 1/4 times a. And a equals -1/2. And then we fill in our k. Well, our k is 3. So I write that out, but you can easily type it into your calculator. 2 goes in here once, 2 goes in here twice. So this becomes 4 plus 1/2. And it should be negative.
Did you put the negative denominator up to the numerator?
I just filled in -1/2 for a right here. So 4 times -1/2 is -2. So it's still in the denominator. So when we simplify this, 4 minus 1/2 is 3.5. If you prefer, you can use a decimal. So let's go back and look at our picture here. is 3.5, is that on the inside of the parabola, which is where the focus point should be? So 1, 2, 3.5, and then 1, 2, 3. Sure enough, there's our focus point, which means that our directrix isn't going to change much. Here, I'm going to switch colors for a second so I can kind of write it beside here. Our directrix then is going to be x equals, and this one's going to be 4 minus 1 over 4 times negative 1/2. H minus that. So the only difference, it was plus here, now it's minus. So the same things still happen here. 4 times negative 1/2 is negative 2. So this is x equals 4 minus 4 minus the negative 1/2.
Shouldn't that be H right there? And H equals 3.
H equals 4. So then we have double negative here. So this is going to be 4 plus 1/2. So we get x equals 4.5. Makes sense. I'm going to go back to this picture here, and I'll pull that back down because I just realized I gave you no time to write that down. 1, 2, 3, 4.5. And again, the directrix and the focus are the same distance away from the vertex of the parabola. It's just that the focus is on the inside of the parabola and the directrix is on the outside of the parabola. And then we're just left with one more piece here, which is the LLR. And it is going to be the absolute value of 1 divided by A. Our A is negative 1/2. Again, you can type 1 divided by negative 1/2 in your calculator if you have to, but how many times does a half go into a hole? It goes in there twice. And positive divided by negative is negative, so our LLR is 2. And that point goes through the focus, and it goes from here and here. I don't know that we know those exact points, but then we measure the distance right there. That's where that LLR is measured on every single parabola for comparison purposes. So, as we complete the square here, one more time, use completing the square method to write the equation of the quadratic function in vertex form. So we haven't done completing the square for a while, so we probably need a little bit of a review on that. But notice, 4x. X doesn't have an exponent on it, so this is going to be another x equals parabola, which are the ones that we haven't had a lot of experience with. Once we put this in vertex form, we will be able to identify all the different parts of the parabola from our chart, like we've been doing for this entire time. But when we complete the square, the first thing that I'm going to recommend is that we move the 12 over to the other side. And we have negative 12 plus 4x, or you can have 4x minus 12. It's not going to make any difference. Equals y squared minus 8y plus something. We're going to complete the square. We need to make this a perfect square trinomial. If we're adding something to the left How about the right side? Then we also need to add something to the left. And I wonder if anybody remembers how to figure out what goes in that box.
Half a negative 8 times 2. Or times it's still.
Yes.
Square.
Negative 8 divided by 2. It's always divided by 2. Is negative 4. And then we square it, which means that we're going to add a 16 here. And we're going to add a 16 there. So now that we know that, over here on the left side, 16 minus 12 is 4, plus 4x. And on the right side, we're going to factor. So I probably will show more steps than you. And I want y.
No, take a look.
I did. So I want x there, right? 4 plus 4x equals y minus 4 times y minus 4. We want those factors to be exactly the same. That's the point of completing the square. Too many 4's in here as the first time I stand up in front of the class and do this. Y minus 4 squared, when we condense it down, equals 4 plus 4x. We can move this constant 4 to the other side. And we end up with 4x equals y minus 4 squared minus 4. I'm sorry that there's so many 4's in there.
4. Divide by 4.
We have to divide by 4 because we want to get x equals. In this case, it could have been y equals. But x had the exponent of 1. So it's not quite so 4 intensive here when we finish. We get x equals. Remember, the number in front of the parentheses is 1. There's nothing written right there. So we can say that this is 1/4 times y minus 4 quantity squared. And then 4 divided by 4 is 1. There's vertex form. So hopefully I left enough space for you to fill things in. Because now it's going to be the same thing that we've been doing over and over and over again. We want to identify what is the vertex. Well, the vertex is going to be negative 1, 4, and before we get too far along, we should identify the fact that h is negative 1, k is 4, and a is 1/4. In general, I've tried to pick examples that work out fairly nicely in terms of the focus and the directrix, because they don't always. But that's what a calculator's for. Our vertex, our axis of symmetry, the line that cuts the graph in half. If we look back at our chart, it's going to be y equals k, which is y equals 4. Our direction of opening here, well, a is 1/4. 1/4 is greater than 0, which means that this graph opens right. And now, let's type this into our calculator, and I'm going to start with typing in the calculator, the y equals format, and then we can switch back and do our x equals. And you might not have to write the table down. It's just something that I find helpful. But if we type this in, 1/4, 1/4, and then x minus 4, y squared, minus 1. Is that what I had? Did I have? Yep, I have minus 1. And then let's go to the table. And we can see a couple points. 0, 3, 2, 0, 4, 1. 0, 3. But we also have negative 1, 4 from our vertex there. 0, 3. 2, 0. And then one more point there. 4, negative 1. So when we come over here to our other table, for our x equals, I actually have this first one wrong because it's down here at the bottom. Right, the 4, negative 1 would be our negative 1, 4. And our 2, 0 would be 0, 2. And our 0, 3 would be 3, 0. Let's see if that's enough. When we go and draw our picture, we're going to use the blue table to draw our picture. 3, 0 over 3f 0 over 0, 2. And we have negative 1, 4. That's our vertex, which we have listed already. And our axis of symmetry would go right through that point. So I only have 3 points listed in my table now. But once again, 0, 2 is 2 spaces away from the axis of symmetry. So on the other side of that, we have a point at 1, 2, 3, 4, 5, 6, 0, 6. Because that point is 2 spaces away from the axis of symmetry. And 3, 0 is 4 spaces away from the axis of symmetry. So on the other side, if we count 4 spaces, 1, 2, 3, 4, we will also have a point at 3, 8. And here's our picture. Opening to the right, just like we said it would. Then finally we can finish by finding our focus, our directrix, our LLR. And our focus is H plus 1 over 4 times A, K. And we're just going to fill in our values. So our H is negative 1 plus 1 over 4 times our A value, which is 1/4. And 4 times 1/4 is 1. So what we've got here is we've got negative 1 plus 1, which is 0, and I haven't even written down my K value here, but K is 4. So 0, 4, I'm going to rewrite 0. Wrong color. I don't know why I'm holding a black pen, but 0, 4. And when we come back here, does that make sense? Over 0, 1, 2, 3, 4. There's our focus point. And again, it's nice if you understand the fact that the focus is the same distance away as the directrix. I don't have to do the calculation for the directrix. It's 1 space away. So there's our directrix right there, but I will calculate the x equals negative 2. But it's going to be x equals h minus 1 over 4 times a, which is x equals negative 1 minus 1 over 4 times the 1/4. So we end up with x equals -1 minus 1, which is x equals -2. Sure enough. And then to finish, we'll do the LLR. Well, we've seen this computation, or at least close to it. It's the absolute value of 1 divided by A. Again, you may need to type in 1 divided by 1/4 in your calculator, but 1 divided by 1/4 is 4. And then the length of the latus rectum is +4 to finish.